Okay, I want to talk a little bit here about ray diagrams for mirrors. Um, if you look here, I'm using a little applet. It's located on the front of their web page. But a couple different things here. For mirrors, three different rays are usually drawn. Okay, the first ray, you'll notice from the object here, comes parallel to the axes and then is reflected through the focal length. Okay. The second ray comes from the object, okay, and goes through F, strikes the mirror, and then gets reflected back parallel to the axes. And then the third ray, which is only really necessary if the first two aren't helpful, comes from the object, strikes the middle of the mirror, and then is reflected back using the angle of reflection, meaning that this angle and this angle are exactly the same. And wherever those three lines will converge, okay, that is where our image is. So just to show you a little bit, okay, if the object is well far away from the radius and the focal length, okay, you get a small inverted image. As we get closer and closer and closer and closer and closer and closer and closer, right as soon as we get to the actual focal or the radius, we end up with a completely inverted image at the same point. Now, if you start to go inside of there, you're going to notice that one of the rays have disappeared, and we're basically only working with the first and the third at this point. We get a really huge image until we reach the focal point. Once we reach the focal point, now the image shows up on the opposite side, because technically these rays that we have here that are reflecting off, they will never actually cross each other. Therefore, the extensions of those, which is in green, show up on the other side. Okay. Now that is for a concave mirror. If we go ahead and we switch to a convex mirror, okay, again, you'll notice that there are three rays that are drawn. Okay, the first one comes in parallel and then reflects off. You'll notice that this one reflects and its extension goes through the focal length, so a little different than the last one, because the last one it reflected through the focal length. This one reflects basically through the focal length on the opposite side. And you can think of the convex mirror as having the focal length and the radius on the opposite side as opposed to the side of the object, because it curves technically towards the object, so the image is formed on the other side here, okay? Also, those light rays never have a chance to combine because, again, they get diverted away from the principal axes, not towards each other. The other one drawn from the object, the third one ray here comes down and hits the middle and reflects using the law of reflection. And again, we've got a ray that is traced along that same line of reflection on the opposite side. Now, I generally only use the first and the third. This one that they have drawn in here, I never really use that, but the first and the third one do produce the image right there on the opposite side. Now, one thing that you should make note of here is that no matter where I take the object, okay, the image is always on the opposite side of the mirror, and it's always smaller. Okay, convex mirrors always produce virtual images that are smaller than what the object actually is.